Hi everyone. This video is about 0625 IGCSE Physics, past paper questions dealing with section 1.1. 1.1 deals with physical quantities and measurement techniques. Under the core section, we have measurement of length, volume, time. And under the supplement section, we have scalars and vectors. And what are the scalar quantity? What are the vector quantities? And the last one is calculation, either by calculation or by graphical method of finding resultant of two vectors which are given at right angles. Okay. So question 1. In this video, we will be going through very few MCQ questions. I will also do the theory questions in the next video. Here, a student has a measuring cylinder containing water and also has a balance. Which of these could she use to find the volume of a small metal sphere? She has no other apparatus. So to find the volume of the given metal sphere, either using measuring cylinder containing water or balance. To find the volume, we don't need balance. To find the volume, we only need measuring cylinder and cylinder containing water only. Okay. Balance is only to measure the mass. Neither the measuring, no, this is also wrong. So this is correct, but this is not needed. Balance is not needed. So whenever you put the sphere inside the measuring cylinder with water, there will be a rise in the level. Okay, if this is V1 and there's a rise in level after dropping the sphere inside the water. So V2 minus V1 will give you the volume of the sphere. So we need only the measuring cylinder containing water. The next one, which row contains one scalar quantity and one vector quantity? Scalar quantities. What is meant by scalar? Which has only magnitude. Only magnitude. The quantities which has only magnitudes are scalar. Quantities with magnitude plus direction is a vector. Now, come on. Energy is a scalar. I think the first one, energy is a scalar. This is a scalar. This is a vector. Velocity is a vector. Velocity is speed with direction. Velocity is a vector. Mass is a scalar. Time is also a scalar. So this is wrong. Momentum is a vector. Weight is a vector. Wrong. One scalar, one vector. Distance is a scalar. Temperature is also a scalar. So option A is correct. Next question. In which row are quantities correctly categorized into scalar quantities and vector quantities? Scalar and vector. Scalar quantities, mass and energy, of course, correct. Weight and acceleration, of course, correct. So it's A. What about B? Gravitational strength and time. Scalar. Gravitational field strength, it has direction towards the center of a planet or a location. So gravitational field strength is a vector. So it's not, it is under the scalar quantities, which is wrong. Speed and momentum. Momentum is a vector quantity. It is under the scalar quantities. This is also wrong. Distance and energy. Of course, they are scalar, but velocity and temperature. Temperature is wrong under the vector quantities. Okay. So option A is correct. A student wishes to measure accurately the volume of approximately 40 centimeter cube of water. She has two measuring cylinders, a larger one that can hold 100 centimeter cube and a smaller one that can hold 50 centimeter cube. The water forms a meniscus where it touches the glass. Okay, sure. So she has two measuring cylinders, the larger one and the smaller one. Which cylinder and which water level does the student use to ensure an accurate result? And she's using the liquid is water. It is a transparent liquid. So whenever you pour liquids, there are certain liquids which have a meniscus, a concave meniscus. And there are certain liquids like mercury, which have a meniscus, which is a denser liquid, which shows a convex meniscus. So here in this case, we have water So it's going to have a lower meniscus, okay? We have to view at the bottom of the meniscus. So where this portion, okay, this portion is touching this division, where this portion is coinciding with the division, that has to be noted. That has to be noted. Okay, so one is bottom of the meniscus, and which one? So she needs an accurate result. Whenever you need for accuracy, always go for the short range. Short range. If you have seen in olden days, doctors will be using a short range thermometer, which ranges from 32 to 40 or 38 degrees, something like that, 32, very short range. Why? Because it is more sensitive, and it gives you accurate value. Anything which is sensitive, it gives you the accurate reading. So anything which is having a short range will always be more accurate. So always go for the short one. So we go for the smaller one and bottom meniscus. Okay. Which quantity is a vector? Vector means magnitude plus direction. Which one? Definitely electric field strength. It has a direction. So electric field is from positive to negative. Whenever there is a battery, so there is an electric field created from positive to negative. So the electric field is having a direction, positive to negative. Electric field strength. Energy is a scalar, mass is a scalar, temperatures, all these three are scalar quantities. Okay, next one. Which list contains two scalar quantities and two vector quantities? Two scalar and two vector. Distance is a scalar, speed is a scalar, time is no, only two scalar, two vector. Force is a vector, velocity is a vector, distance is a scalar, mass is a scalar. B. What about C? Mass is a scalar, 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 vector. Wrong. Okay, this one is vector, 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 scalar, again wrong. Okay, so only option B is correct. Which vector diagram correctly shows the force Z as the resultant of forces X and Y? You would have learned that whenever you are dealing with two forces at right angles, like it should be either like this. Suppose if there's an object, this object is subjected to two forces, one along the x-axis, the other one along the y-axis. Then the resultant can be like this. You can find the resultant by completing the rectangle and starting from the object. Okay, this is the object. An object is subjected to two forces or two vectors, okay, vector 1 and vector 2. So now the resultant vector will be from the object going to the other end of the diagonal, okay, starting from the object to the other end of the diagonal. So that would be the resultant direction. This is one method. There's one more method is like if you have a vector, I take the same one, two vectors, like you start from the object. So one vector is, this is V1, then again, to the head of this vector, you put the other vector tail. The tail of the other vector comes over here. So head to tail, okay? So head of the first vector meets the tail of the second vector. So this is vector 2. So now the resultant will be in this direction. If you see, the resultant is here, going like, towards the right, the diagonally right. So here also the same. So the resultant will be the same whether you follow the first method or the second method. So here, let us see. So X and Y. If we take this, obviously, suppose if you take this, the resultant should be, did you see? If you apply the first method, actually the resultant should be in this direction. Okay, so this is wrong. X and Y, again, the resultant should be in this direction. Diagonally, it should go to this side, okay? From this point towards the right on to that diagonally right to the top. So this is also wrong. How about this one? X and Y? No. If in this case, if it is like this, X and Y. So the head of X meets the tail of Y. So it should start from here. This is the starting point, X, Y. Then it should start from the starting point to the finishing. That is the resultant. Okay, so this is also wrong. But here the Z is in the opposite direction. So it is wrong. Now for D, so D is the correct option. You see here, X, the head of X meets the tail of Y. Then it starts from here. From here, x goes to this point. The head of x meets the tail of y. So the finishing point is here. Join the starting point and the finishing point. So that would be your resultant vector. So this is option D is correct. Okay. Forces of 3 Newton and 4 Newton act at right angles as shown. What is the resultant force? Yeah. So they have completed the rectangle already, which is very easy for you. Now you just from here, because this is the starting point. So the two vectors, object is subjected to 3 Newton and one more force, 4 Newton along the x-axis. So 4 Newton along the x-axis, 3 Newton along the y-axis. So they have already completed the rectangle. So it should start from the object and it goes to the other end of the rectangle. So diagonally, it should go along O and 1. So it's 5 Newton. Why 5 Newton? You can apply the Pythagoras theorem. 3 square plus 4 square will be like, this is 9. 9 plus 16 will be 25. So you will get 5 Newton. Yeah. So 5 Newton along OY. Okay. What is a vector quantity? Definitely, this is a scalar. This is a scalar. This is a scalar. So it's a weight. Weight, because weight is the force due to the gravity acting on an object. Weight is the force due to gravity acting on an object, acting on an object. So there is a force towards the center of the location. So an object is subjected to weight towards the center of the location. So there is a direction. It is a vector quantity, magnitude with direction. Which quantity is a scalar quantity? Acceleration is a vector, it has direction. Force is a vector, it has direction. Time is a scalar. Velocity is speed with direction. Speed with direction. So again, it is a vector. Speed with direction, so it is a vector. So this one is a scalar. Time is a scalar, so it's C. How many of the quantities shown are scalars? Mass is a scalar. It has only magnitude, no direction. Momentum is a vector, okay? So it has mass times velocity, mass times velocity. So it is a vector. Density is a scalar. Energy is a scalar. Whatever energy it is a scalar quantity. So including kinetic energy, it is a scalar quantity. So here, there are three. 1, 2, and scalar. Energy is a scalar. Okay, 1, 2, 3. So it's 3. 3 quantities are scalar quantities. Okay, a student investigates a pendulum. He measures the time for the pendulum to complete 20 oscillations. 20 oscillations. He repeats the experiment 3 more times. So totally he is doing 4 times. The readings are shown here. Okay. Then what is the average period of the pendulum? Okay. So if you find the average of 20 oscillations, it's going to be like 17.6 plus 19.8 plus 17.6 plus 18.6 divided by 4. Yeah. Then that gives you 18.4 seconds. Okay. This is the average of time for 20. This is the average time for 20 oscillations. Average for 20. This is the average for 20 oscillations. But we don't need the average for 20 oscillations. We need the average for the period of the pendulum. What is period? Period is equal to time taken for one oscillation. So what are you going to do? Here it is, the student has found for 20 complete oscillations. I want the time taken for one oscillation. So I have already found the average. So it's 18.4 divided by 20 will give you the average time for one oscillation, which will be 0.92 seconds. Okay, so it's B. So did you see here? They have also given that one 18.4. So if you only find the average of 20 oscillations, you will be choosing D, but it is not the right answer. because they want the average period of the pendulum. Period is time taken for one oscillation. So you have to divide by the total number of oscillations. Okay, so average time, total time taken for 20 oscillations divided by 20 will give you the time for one oscillation. That would be the period of the pendulum. Okay. Which measuring devices are most suitable for determining the length of a swimming pool and the thickness of aluminum foil? Swimming pool is having a greater like distance is more. We cannot use a ruler, isn't it? So ruler cannot be used, and thickness of an aluminum foil cannot be used. A measuring cylinder we only use to find that for volume of an regular or irregular object. Tape measure, of course, we can use tape measure to use the length of a swimming pool. Oh yeah, thickness of an aluminum foil definitely can be, micrometer can be used. Tape measure and ruler. No, ruler you can't use. It is, for thickness of the aluminum foil is going to be in the order of micrometer. So it is better, or even if you, definitely not more than millimeter. So, and that millimeter also is going to be like very, very small, like 0.02 millimeter, something like that, which we can't use a ruler. So the tape measure, and this is wrong again. Sorry, this is correct, but this one is wrong. Ruler can't be used. Micrometer screw gauge is correct. So where both options are correct is B. Length of a swimming pool can be found using a tape measure. Thickness of an aluminum foil can be used using a micrometer screw gauge. Okay. Very small values of which quantities are measured using a micrometer screw gauge? Of course, it's distance. Micrometer screw gauge is used to measure the small distance, like thickness of your hair, the diameter of a thin wire. So they all come under the length. Okay, thickness, diameter, they all come under length or distance. So distance. Okay, it's not for time, pressure, moment. These three are wrong. Okay. Okay. That's all. Thanks for watching. Please like, share, and subscribe. I will see you in the next video with theory. The theory part is like how to draw the vectors, the resultant vectors, okay, which are at right angles. Okay, bye. Take care.